Hello again. We had an hour break from me. um, Today is getting very hectic. Surprisingly for a stream, except also maybe not surprisingly. But I hope you had a chance to take a break and play some games or even go get water and a snack. I barely did. I had a meeting between this, so bit of a running back and forth. But my hope is that we'll actually be able to take our time with this mini workshop where we'll learn more about Python in a way that can get you ready to go for this week's AI and machine learning projects. Python is a pretty popular language to use, especially when you're getting started in learning for a number of reasons. And my hope is to make sure that you're understanding working with the code, whether you have a background in it or not. So it's a little bit of like, how do you code in Python? As well as like, what can you do with it? So that way, as you jump into these different AI machine learning workshops that our other MLHers are offering, that you're not like, oh my gosh, I need to learn this language and all these concepts. It's more like, all right, I have enough of an understanding of this language. I can really focus on the concept. So we're really trying to set you up for success, which is why, again, we'll take our time. We'll be gentle. We'll have all the time for questions as you have them. Make sure that basically you're good to go. Obviously, not every coach will be using Python, but it does help you like gear your mind toward things, and you can pivot as you like depending on your preference. So if you didn't get a chance to check into the event, definitely go ahead and do so. But like I said, my goal is how to get you started quickly and understanding what you're looking at, because that can be very intimidating. I would know I'm doing that as my prepare for my like job interviews and everything. And then I also want to make sure that you can see what pathways you have ahead of you for using Python in your future. And then how this might transfer to other languages, particularly if this might be your first time using Python. But you might be coming from no coding to coding in Java or just working with JavaScript, maybe even Golang. There are plenty of places that folks tend to start. And then like, well, what do you do next? What if, so to speak. So to get us started, we'll actually just jump right into downloading Python. And so if you go to python.org/downloads, there is a current release for Windows because that's the machine I'm currently working from. If you're on a MacBook, it does come by default, I think in 2.7, although they may have changed that with the most recent Windows. But you can go ahead and download it through the python.org downloads. If you're working with a Mac, they have, again, their own installer that you can go ahead and use. Now, I already have Python on this machine, so I'm not going to walk you through it, but I do want to show you around the documentation and the website specifically. So there's the documentation and then the PEP index. So the nice thing about Python is that it is very beginner friendly. As you can see, there's like the documentation, there's talks, there's guides, depending on whether you're a beginner or a developer. Frequently asked questions if you prefer to learn programming and not English, or you need that to get started. Like, actually, I'm kind of curious about this one. I want to see what languages they have. And then there's also lots of books and essays that people have published, written, have made available, etc. So there is no shortage of resources. If you decide to learn Python, if you decide to delve deeper than just what this workshop will get into, which is very much a like broad, what can you do with it? What is it like overview of it. And of course, as always, if you're not familiar with my streams, or if you've never been, or this is your first time, I very much welcome questions. I love answering questions because it means together we'll have a deeper understanding of things. And if, let's say in the future, you need to come back to this video or someone else does, they can benefit from having had a question answered that they may have had, but may not have been able to have answered because they're coming back in the future. So, hello, welcome. I appreciate y'all showing up. Yeah, so like I said, we're getting into downloading, and my thinking is while it's downloading on your end, let me go ahead and paste a link in case you're looking to download while it's downloading, because I'm sure that takes time for some folks. We can go ahead and talk about what else is there. Yeah, Mac and Linux have Python 3.9. Okay. Oh, cool. I had no idea. Is it actually? No, it's 3.1. Is there a 4.0 or something? No, there's 3.9. Well, we're already at 3.313 or 3.13. So yeah. I remember back in my day it was 2.7. Yeah, that's old. Anyway, Python is very beginner friendly. So again, there's the beginner's guide, which I have pulled up, / for non-programmers, which is super nice, especially if you are not familiar with programming at all. And there's no shame in that. I won't say it's easy, but I'm not going to tell you it's like impossible. It just takes perseverance. And if something doesn't make sense, find a different resource. Just because one thing doesn't work doesn't mean that all of it doesn't work. Alrighty, so Python's documentation is that there's plenty of information in the what's new, but I more specifically want to walk you through the beginner's guide, more specifically because this is what you most likely might interact with. As you can see, there's different languages, which I was curious about that. What? No, what do you mean it doesn't have? Shame. Apparently, though, there are for non-programmers, so I'll put these up. I know that you don't probably have access to this right now because it's not very zoomed in. But as you can see, there's a beginner's guide to Python, and there's a beginner guide for non-programmers. And so personally, I've actually read some of these books, these like Automate the Boring Stuff and How to Think Like a Computer Scientist. I haven't actually done one-liners or Think Python, but these are very nice books. And if you want to interact with them, I'm pretty sure that some of these, their website is like they're free. Yeah, so each of these books can be purchased online, but it's also available as a free textual website or video content. And I got y'all. So here's a link if you want to check those out. But again, like Python itself also has their like beginner guides, which we're looking at. Does this link work? No, it's going to be a broken link. But they have lots of tutorials and other in-browser things that you could use to help you get started. So I'm not really going to go into any of these tutorials. I just want to show you what resources are available because Python is the best out there as far as making sure things are accessible. I think a pretty close second might be actually Rust because Rust follows a similar profile of just like, how do you consume content instead of just like, here's the documentation. And then you read it and you're like, I didn't get that. Because there's a little bit more involved in just like understanding documentation. So let's see. So they have examples, they have mathematics, and this is relevant to us for a number of reasons. And they also have simple examples according to the programming guide. But this quizzes and exercises if you want to be that, Python-based AI and prompt engineering, specific modules. This is just really helpful to get you started. But if you have no idea what you need or what you want to do, then that's what this workshop is for. And let's see. Again, more courses. Highly recommend. If you are teaching your family, kids, cousins, etc., lots of tutorial websites. Point is, this is a chunky documentation that is full of lots of things to help you out. And so what you might see a lot of our MLHers using is Visual Studio Code, which is a popular IDE or basically a code editor that allows you to also compile things and work with things and run your code. And so a lot of us will use Visual Studio Code, but for Python, you also have the IntelliJ series of editors. I think IntelliJ's Python editor is PyCharm. And so those tend to just optimize your experience with working with specific languages. So like I said, I'm using Python, and this is a preview of what will come, where I was like, what if you wanted to use Jupyter or something else, right? But again, there's lots of examples and sample code. The standard library. I had no idea. I thought they would give like a list of stuff. I thought there'd be a little more. But it looks like they have code samples. Mathematics. I haven't actually looked at these specific links. Okay, here's our examples. This is what I actually wanted. So Python is meant to be very readable, where you should be able to say, well, print hello world means print the phrase hello world. And so as you get more familiar with things like quotation marks, which end up embodying strings or the words that you're reading, that you can start manipulating them in different ways, much like you would a math equation. And then much like math equations, you might have functions to do specific operations more than just math. And then you can start testing like, what are things equal to, and getting into more of the nuance of what things mean. where you might have a class, which is a way of saying, hey, I have a template that I want to repeat in other instances. And right now, this class is not a great example, I would admit. But like the way I explain classes tends to be, let's say you have a filing cabinet that is for text documents, and another filing cabinet is for books. And so you now have the same cabinet that holds similar data, but it's a different format and different expectations. And so now your filing cabinet is your class, not the formal designation, but you might say book is your class or tax is your class, depending on how. And the only reason I'm mentioning tax documents is just because I have to pay my taxes soon and I'm thinking about my taxes. But a book might be a little easier, or like a library, like a public library that you go to go check out books. That can become a class. And so you look into like object oriented. But Python is nice that you can do a little more than just object oriented. You can also do, I think, functional, or at least scripting. So Python is very popular to just spin up sample code, test projects, etc. It is used in industry as a genuinely supported language and like very in depth, and there are some very impressive projects out there. But I find that when you enter the world of AI and machine learning and computer vision, the most common reason people go into Python is because it's easy to read and understand. There are tons of libraries and support for it, and that they can just jump in and get started and kind of start to sort out what they're looking at, which is much better than I would say than like MATLAB or like Java or R, which requires a little more background, such as like math and engineering for MATLAB and R, or if you're like using another language, you might need to have more about what are the strengths and weaknesses of that language and so on. Okay, so I've talked your ear off about Python. I haven't really done much else. So we've downloaded it, we looked through the resources. Let's go ahead and learn how to write Python like legitimately. So like I said, there are two ways to go ahead and do it. And so I'm going to make a new file and call it main.py. We're going to ignore that main.ipynb for a little bit, where I'm just going to say that same example, hello world. And this is like almost grotesquely simple compared to the things that the coaches are going to be doing this week. But in order to read it and make sense of it, you probably want to be like, well, how do I even run my code? Like, what can I do with it? And so like any coding language, if you're familiar with other ones, you are able to write functions, do math, affect strings, process data, etc. But the way in which you would simply interact with it is just you would say Python, which is a language, of course. I'm using a terminal. Let me zoom in a bit. To interact with Python, I already have things installed and hooked up, but when you open Visual Studio Code, there might be like, hey, would you like to install a Python interpreter? If you're using PyCharm, I think things are automatically just included. It just says link to your specific installation. But I want to run main.py. And so right now it's printed out hello world for me. And this is how I would interact with it from a scripting point of view. So something I've done in a past Global Hack Week stream is that I set up a database and wrote data to that database and then queried that database, all from a Python script, which is one way in which you can use Python. Let me see if I can actually open that up really quick. Nope. It's very far in my history. Where is it? What did I name it? Yeah, so here we go. The file is not found. What do you mean it's not found? What do you mean it's not found? Okay, that's awkward. What happened? Why did it? Okay, that's awkward. But a previous stream I did on Python was where I wanted to process all this data. And so that was something that we could do with Python if my file existed. Today I learned it doesn't exist anymore for whatever reason. I don't understand. Did I just delete something by accident? Go figure. Don't know what happened. Awkward. But I was able to programmatically process this data. It doesn't look very nice because it is in a CSV, but I was able to process first name, last name repeatedly, along with family relations, ages, etc. And so as we look towards AI and machine learning and computer vision and anything else you might want to do, everything starts with data. So Python is actually very efficient in processing data, whether it's a CSV, an Excel sheet, what other types of data is there? Databases, etc., because there are a number of libraries that enable this for you. And so what you might use varies on your approach. And so this gets into more about like pathways. So if you are doing AI and machine learning, the most common libraries you're going to see are Matplotlib, NumPy, and Pandas. And so I'll go ahead and just pull these up. So I have Matplotlib actually up right here. So Matplotlib is a graphing library where if you wanted to process your data, let's say you wanted to do descriptive statistics, so line charts, bar charts, group charts, plotting categorical variables, as you can see, there are plenty of features that come with Matplotlib which allow you to visualize your data in a way that's mathematically comprehensible. And so for researchers, this is like all hail, end all be all, amazing stuff, right? But as programmers, we're like, well, what do we do with this? Like, what does this mean? Do we need this? And to this, I would advise actually, if you are going to work with data and you are going to work with AI, machine learning, etc., that you consider the story you tell with the data that you collect or the data that you use. Because there are plenty of projects out there that say predict this person's chance of heart failure based on all their medical data, or predict this person's this, or determine whether or not this image can be segmented into the skyline and the ground. And so these are clear questions of where you're asking, what can you do with the data that you've been given, whether it's two-dimensional data such as numerical, X, Y, or it's image segmentation, again, where you're creating and simplifying images into singular binaries of labeling and whatnot. And that's just from past experience. There's other ways you can interact with this, where maybe you want an interactable like pie chart, bar chart, where you want to be able to hover over things and see more about it. So let's go ahead and go look at animation. You can show all these wonderful things, particularly if you want to expand. Let's say you're working with embedded systems and you have home sensor data. So you want to look at the data as it comes in from your sensors outside your home. Or if you're working in radio astronomy, you will actually get very interesting animated like images as far as like color mappings, because they're working on dimensions far beyond our understanding. But the point is, there are many ways to demonstrate the data that you're working with in a way that other people can understand. And so the best way to explain this is what works for you. And depending on the data that you're working with, you'll end up figuring out what you end up needing. So Matplotlib, all hail, does lots of different things. This doesn't mean you actually need to use Matplotlib, though. There are other like plotting libraries, data visualization libraries, if you're at that point, etc., that do similar things but have different strengths. And so as you proceed from, okay, I made this, I've trained a model, I've trained something, I've done this, I've done that. Now I need to make meaning out of it and put it to use. That's where you start looking at these Matplotlib libraries and whatnot. And so I also mentioned like NumPy. What even is NumPy? And so like, let's zoom in a bit. NumPy is meant to optimize computing, particularly on arrays and multidimensional data. And so when you're working with computer vision, AI, etc., machine learning, this becomes incredibly important because you might need to transform your data in various ways, whether it's, oh, I need to combine things and multiply it, or do matrix multiplication, linear algebra, statistical operations across every possible array field. The list goes on. If you were to do this by hand, you would basically be reinventing the wheel, and you'd also be slowing yourself down. NumPy means to do this better for you, where the more dimensions of arrays you have, the more it can handle. Whereas if you have to write this yourself and have to say, yes, I'd like to use my GPU, yes, I want it to do these things, life becomes a little bit harder. So NumPy steps in as a way to basically break it up for you. It handles all the optimizations, handles managing your arrays, and all you have to do is just know how to use it. And so, as always, libraries have nice documentation-ish. because this is such a big thing for people in data science and manipulating data, etc., there are plenty of guides, as you can see, to the absolute beginner's guide versus just to the user's guide. Depending on where you're coming in at, I'm sure there's also plenty of tutorials on YouTube. So NumPy is a very common library that folks use, and then the other one is Pandas. And so this is used to do that processing of data that I mentioned, you like working with CSVs, working with Excel sheets, working with other forms of data collections. And so the goal is to zoom in. Let's go to the user guide, where the goal is to work with cleaning up your data, processing it in a way that's meaningful. And so all of these collectively allow you to have this very optimized pipeline of working with data, fixing the broken parts in the data, because data is not perfect, especially when it comes from the real world. And then also making it visualizable such that humans can understand what you've been working with in a summative or aggregative form that actually makes sense, instead of like this spreadsheet in column A, B, and C versus, rows 257 kind of thing. Yeah. So this helps break it down a little bit into ways that you can communicate with the rest of us. So again, these are common libraries. If you decide that you want to go into the machine learning AI side of things, like machine learning specifically, I think you'll get into more of like statistics and what specific, what's it called? Not algorithms, models or equations that you might need, particularly if you're doing predictive modeling, where you might use specific like linear regressions or a specific method of doing calculations to figure out like how you might have best line of fit, normalizations, or if you are not doing normalization, in which case, like, why are you not doing that? And you should explain that. So that leans into more statistics. If you're doing computer vision, you might have, oh my God, TensorFlow is very popular. And then you might also be referencing other people's models. And as you get into AI, you might also be referencing models that exist, such as ChatGPT, Gemini, or OpenAI, I believe is ChatGPT's. Perplexity has a number of models. And so depending on if you want to train an existing model on, say, embeddings, where you have a bunch of documents or data, like you could even say, hey, I want to train Gemini on embeddings from the Python website on documentation to organize an optimized curriculum for me who needs something like, let's say I need a video once every like 4 concepts, but I also need to make sure that these concepts are capturing the nuance of like, hey, if you know this language, this is not the same in Python, and so on and so forth. So lots of different ways you can do projects, but all requiring different libraries. Now, moving beyond the realm of AI machine learning, let's go ahead and open this up. Let's say you actually want to go and go collect all the data because it doesn't exist yet. For whatever reason, you need to process certain websites. And this is going from AI machine learning, the beautiful like abstract thing that you're like, just use an API, just use the model. What if you need the data for it? And so that's when you'll look into Beautiful Soup or other parsers that handle XMLs that are websites to process it into something meaningful, so that way you can actually use that data. Particularly, let's say you wanted to, God forbid, scrape the MLH website of the upcoming hackathons. And let's say you're like, but I really want to make sure that I capture all the upcoming dates because I want to like show the family tree of hackathons or something. And maybe that's something that like Beautiful Soup might help with. Obviously, read terms and conditions on websites and whether you can scrape or not and what that means, because you might get your IP blocked, but Beautiful Soup is made, like, I think it's on version 5 now. But that's really helpful in processing information that you find online that isn't necessarily cleanly cut and set up for you as you would in other situations, such as tutorials for AI and machine learning. And then as you get into realizing, well, I need more information, I need access to things, I need API access so I can actually work with these things, you might look into the operating system library and the .env library, which allows you to store secret things that you're like, this should never be public. This does not belong in the public because they are mine and I pay for them and I don't want someone using them. And so if you transition into more of like a full stack approach, or perhaps you want to demonstrate your work on a portfolio website or showcase how like incredible your model is and allow people to interact with it, then you'll start getting into full stack development, which is going to be your os.env libraries, etc. you can access this recording on YouTube. So we are very much deep diving into like what can you do before we do like a very basic project at the end if we have time. But yeah, you can watch it on YouTube. It'll be up right after the stream is done, I'm pretty sure. Just go to youtube.com, search up Major League Hacking, open our portfolio, and you'll actually be able to see all of the folks who are streaming. You can see all their past streams that we've recorded. But good luck at work. Thanks for trying to attend. Be a good human, all that jazz. But continuing on, so os.env is a very popular set of libraries. Like I use it all the time, anytime I have to make API requests. And if you're not familiar with this at this point, it's because you haven't been exposed to it. And the way an API works or wanting to access certain things, you need permissions, which come in the form of keys. And so APIs are, let's say you wanted to access all the possible books in the world. And so there's an API out there that might have a list of all those books. And maybe you're like, oh, well, I want to access all the books from this author. And so there's different ways that you can interact with the website or with the API such that you can query it and it will send you stuff back. But in order to make sure nobody's abusing it or costing resources, because, a library is like a physical, like public library costs money, and they don't always have enough money to store all these things, then they might, rate limit your API access. And so that's where a key comes from, because they're like, yes, we've given you access. You are allowed to do X, Y, Z. You want to query us for books? Okay, here you go, until you've reached your limit, for example. And then we have the HTTP libraries, which gets you into more of that, like being able to actually make those requests. And then as for how you might host it, well, it depends. So if you want to do a static website where things are not generated or needing to be updated regularly, you'll consider a Flask-based server where Flask will spin up everything you need on the back end. You'll set up your orientation of, here's the data structure and here's the data I'm expecting and here's the website I want to show. And things are not updating live every minute or something like that. At that point, you might consider Django, where Django will allow for that like dynamicism that needs to happen, and so on. Now, it is related actually, but the other possible option for you to go, if not AI machine learning, full stack, or like embedded systems or whatever, is actually to make games. And there's ways that you can have games interact with the real world, whether it's collecting sensor data, or maybe it's a game that is, using an AI to help generate some of the terrain. So I think it's called procedurally generated terrain or procedurally generated levels and stuff. So it makes all these things like feel new each time, right? And so with Pygame, that is the very common library for folks to get started with like making interactive games when they don't shift to like Unity or Godot. Like you can recreate Tetris, you can recreate Pong, all sorts of things to get you familiar with however it is. And the reason I'm mentioning all these different libraries and different pathways you can use is because maybe there's something that speaks to you, and that is your way of getting motivated and interested in learning a language. Now, I have a PhD now. Oh my gosh, I can say that. But the thing that I learned the most is that when we are taught in school, we are often taught to a specific expectation that says, you must learn it this way and only this way. And if you have not had that experience, you are very lucky. But many of us are told this is the way you must learn things. There is no flexibility. But the reality is everyone learns very differently. And as a result, what works for one does not necessarily work for you or others. Whereas for me, I know that I sometimes can watch videos. Rarely. In fact, I never watch my old streams or anybody else's streams because I simply can't pay attention, and that's just my fault. It's not a problem. It sucks. I would love to consume other content, but I can't focus. But as a result, I'm very good at reading documentation and looking for examples and reading Stack Overflows because I prefer to read to consume content on how I learn. That is not the most effective way. That is not the most optimized way, and I don't know what is. But the point is, whatever works for you is the optimal way. So I want to make sure that that's very clear, that even though I've shown you all these different resources, you don't have to use the documentation. If you prefer to watch a YouTube tutorial on how to get started and then backtrack through the documentation, or you prefer to ask questions as you're learning, or you prefer to make projects and ask questions never, however you prefer to do things is fine. There's nothing wrong with that, unless you are making horrible things that affect all of us, in which case I will silently judge you. But the point is, if you decide, I still want to learn AI machine learning, but I want to do it through video games, that's possible. All you have to do is blend some libraries together or figure out what serves what purpose and how you might merge them together. And so it serves to reduce some burnout because you're actually motivated to learn a thing. So I've yapped for like half an hour about all the different things you can do. And I want to introduce you to Jupyter because in the spirit of AI and machine learning, this is something you'll run into quite a bit. In fact, I think there's at least a few coaches I know that definitely use Jupyter because that's the field they work in and all this other stuff. But Jupyter is another way of interacting with Python, but it gives you some optimizations that are pretty cool in that you might find curious, especially if you're like learning how to code or like just testing things on a small basis. And so that's actually what I had initially up, but let me go open that. Open folder, Jupyter. So we're going to go ahead and ignore that main.py, and instead we're going to go ahead and make a new file. And I'm using very typical Python names and not actually like notebook names, but that's okay. So right now I have Jupyter set up for me already, but very quickly, if you wanted to have a Jupyter notebook in Visual Studio Code and you didn't want to set up your kernel because I was too lazy to do that, but you can do that. The way I did this is I actually scroll up. Oh, it's not going to work. If you go through the documentation, it'll tell you how to install it, but I'll still work through. Jupyter, how to install. So Project Jupyter. So Project Jupyter, first you're going to just hit pip install Jupyter Lab or Jupyter Notebook. But if you want to be mindful of not having global installations, and so if you're not familiar with this, I want to give you a quick preview where a global installation is like when you downloaded Visual Studio Code and you said, well, I want every user on my laptop or my desktop to have access to Visual Studio Code. But what if you wanted only a project to have that scope? Because you're like, well, every project uses a different version of Visual Studio Code or Word or whatever your preferred app is, right? And so with Python, you can create environments that store different versions of different things. So let's say I was working on one project that required an older version of Python due to cross-compatibility with any of those libraries I just mentioned. And that happens where the more libraries you add, the more you need to consider where's the cross-compatibility so they actually work as intended and don't introduce issues. And so the way to do that is to use virtual environments or PyEnv or Conda or Mini Conda, or I'm sure there's more. There are many different environment managers for Python. I'm going to teach you virtual environment because that's the one I use these days. It's very lightweight. It doesn't suck up memory, but you'll find that a lot of researchers will use Conda or Mini Conda or even like other variants even within that. I've stopped using Conda actually in the last year and a half because it just never worked for me. I just kept having to update and I would be in update doom. If we come back here, you'll see that I have this folder called Jupyter. So I'm going to go ahead and delete it and we're going to remake it. And so what I am going to do is, again, I'm on a Windows machine. And so you can mostly do everything similarly in a Mac or Linux machine. But what I want to do is Python, I think it's -m venv, which if you don't have this, you'll have to probably install Python. Like it's going to probably be pip install venv or virtual environment. Actually, let's just Google this before I make assumptions and then break your computer. Python install virtual env. Okay, so I am using pip, and so you could use python-m pip install based on a user, etc., or just python-m virtual m. And at this point, with the way that my stuff works, I just have to do pip install virtual env, and then it works. Yeah, pip install virtual env. I think it's vn because that's just how we use it, but whatever. So pip install virtual environment. If it does not work, you might need to say pip3 install virtual env because you might have different versions of Python on your laptop, desktop, etc. So once that's installed, you can go ahead, and so that can be done here in this terminal as long as you have access to a Python version here. And so of course I do have that access, so it is going to cooperate with me. And so again, I have. a version of Python, as you can see. So if you don't have any of these things, then obviously go install them. But in order to, again, once you have Python installed, I'm going to name this environment actually Jupyter, because I'm like, I want to be specific, you know? And it's going to yell at me. Great. I probably did something wrong. Cannot open. What am I doing wrong? How do I use user guide? This is why I use this. Okay. Virtual env. That's why. I wonder if I can just do it like this. Virtual environment Jupyter. Still not recognizing it. Create environment. Creates folder. Windows. Why do you hate me? It did work. Can't open. Oh, because hang on. Delete permanently. Come on. That's probably actually why it's conflicting. Whoopsie. Delete. Yes. Yes. Cannot unlink. Oh, it's because I said it. Okay, I understand. I accidentally linked it to my Visual Studio Code, which is why it's freaking out. Yeah, I know. You're not going to let me because I linked you like a moron. That's okay. Let's just start a new Visual Studio Code window with a new folder, so at least I can prove that this happens. I promise I know what I'm doing. New window, new file. Okay. Later. Let me just really quickly save this. Repositories. New folder. New folder. Chip 2. Let's just save it as that. Cool. Okay, so I made a new window and I made a new IPy NB. So that's different than normal Python. So normal Python is going to just be like main.py, right? When you're using a Jupyter notebook, which I will show you the fanciness in a moment, it's going to have a different file ending. And you can see, like, just off the bat, there are some things that you can do that are very different than a normal Python file. We'll get there. Okay. Come on. Oh, duh, because I'm on Windows. Sorry, I've been on Mac for like weeks. This is the first time I'm coding on my desktop in a hot minute. Alrighty. What did I call this? Jupe 2. Yeah. Okay. So we're in the folder that I wanted to run this in. Jupyter. Does not like it. This is why we can't have nice things. Virtual env. Jupyter. Nope, I'm doing it wrong. Windows and create. Creation never. Oh, I'm in the. I think I'm in the wrong documentation. That's why. There we go. That looks more like it. That looks more familiar. Python.m Jupyter. We'll just name it again. Okay. Python-m. Come on. Open folder. Do select folder. There we go. Okay. Later. Great. We have finally fixed it. So we have an environment. Visual Studio Code making a fool of me. And what I want to do is I want to activate it. And so I believe it is source. Yeah, I need to go through this. Scripts. Tell me I've been on a Linux machine for a hot minute. Use the wrong slashes. Okay, so now I have a virtual environment where it's currently running a environment that has Jupyter on it that we're going to go install it. But now this is a localization. We're going to do pip install notebook because I think need to install Jupyter Lab. I'm not doing as much. Yes, so I'm not really using Jupyter Lab. This would be a way to open a local instance of Jupyter, but I just want the notebook. I just want to mess with things. And so to run it, there's different ways to create interactive playgrounds. Because I'm doing this in Visual Studio Code, it isn't really necessary, but we are using it to install some libraries. So it's thinking for a hot minute. And we don't need to look at this anymore. We're just looking at this. But right now you can see, right now there's a preview that says ask Copilot to do something. That's great. But we also have all these extra buttons that don't appear in a normal Python file. We can generate code. We can add a code cell, a markdown cell. We can run everything. We can select a kernel. And what does even all this mean? And so the best way to explain this is to show it. And so normally when and I showed you this, when I wrote the original Python file with the hello world, I had to go through the terminal setup and I had to say Python, run my script. And so in this instance, I don't even have to do that. I don't have no, come on, run my code for me. Run my code. Come on. Okay, so it created a kernel for me. And so it ran that single line right here in the cell, which is really nice. And if I wanted to do an edit to it, let's say I also wanted to say, I want you to do some math, and I'm going to say import math. I don't know actually the math imports right now. What's a good example? Let's say, for I in range, print I, sure. And I want it to do both those things. And so now I can rerun it. And it's doing that for me, which is really nice. And I can go ahead and clear those outputs. So we'll go ahead and clear that output. And I'm going to add a markdown cell. Beneath it, I'm going to say this is a markdown cell. And we're going to give it a markdown header. And if I say run all, it's going to still run that same bit of code again. And it's also going to give me some markdown formatting, which is very nice. Now you might be wondering at this point, like, well, why are we learning about this? Why can't we just do Python the normal way? And the answer is, well, if you want to do AI, machine learning, etc., do you want to run your whole script? Maybe it's, 500 lines long and there's all these functions and all these things and you want to run every single thing over again? What if you want to test specific cells of code? Like maybe my first cell is like, just does Python work? And it does. Yay, great, fantastic. And now I want to know, hey, like this is going to be my title and I'm going to add a new piece of code. And actually, what I'm going to do is go find, not that. That was a mistake. Where is that? I'm looking for my tabs. Where is this? I had a matplotlib. All right, we'll just matplotlib. Examples. Let's go to, I like bar charts. Let's do a bar chart. Cool. So you can see this formatting is very similar to a Jupyter notebook. Who'da thunk? What if we wanted to copy all this? Or what if we only wanted to copy this code and run this specific code? Let's go back. I know what I did. We're doing it. Let's say I wanted to run all this code and only this code, but I don't want to run this again. We don't need to worry about this. We know that that works and we're going to move on. And so I'm like, oh, well, if I run this, I know I haven't done something. We're getting there. So right now it's going to yell at us. And I did that on purpose, where I'm going to run this specific cell and it's telling us, hey, you don't have certain things, which is I don't have NP. It's not defined. And that's because I didn't import it. But now I'm like, oh yeah, I forgot to do that, I guess. Let me go and copy that. And I could put it here, and then it would be fine. I actually don't have it installed yet, so I have to go back and do a pip install. Or I can just put it up here in this cell. I can replace this. I can rerun this cell, and I can make sure that it installs things, which again, I haven't installed this, so let's go back to our terminal. And we're going to do pip install matplotlib and numpy, because I don't have it. And while it installs, honestly, that was really nice and easy. It's really easy to just dump things in and keep going. It's thinking for a hot second. And if I run this again, it imported. And there's no output here because I haven't had it output anything. But now, if I go here, I only have to import it once. I only have to run parts of the code at different points once. And so let's go back here. And now I have a bar chart with penguins, which is really nice. And this is an output that I could use in a research paper, use in a blog post, show people like, hey, I just made meaning out of my data. And I can run things in different sections. I can even make quick changes to this. And notice that I don't have to run this cell anymore, unless it's just a stale cell, in which case I need to run it all over again. But the point is, you can make changes to subsets of your code, which makes it great and easy to do testing, to do data visualization, to make sure that your functions work, that whatever it is that you're working on is just easy enough to test in chunks. Versus if you did it with a main.py, you'd have to rerun the whole file each and every time. And sometimes that's tedious, and sometimes that's by design, depending on the direction you go with your work. Now, can you make a game in Jupyter? With great difficulty. I would not recommend it. However, let's say you're testing the mathematics behind your game, like mechanics or physics or something like that, and you want to just have it calculate some things, show you some graphs, do whatever it is that you need to do, in which case this is very simple, and then you just port it over. So it's very cross-transferable on what you'd like to do, but you'll find that most scientists, AI, machine learning, computer vision, are probably using Jupyter notebooks to demonstrate their work, give you tutorials, and a variety of other ways to interact with it. Oh, I would love to interact with that. I wonder how it works with Obsidian. I've seen a lot of people making a bunch of different extensions with Obsidian, and it's kind of interesting. Thank you for coming. I am so glad you got a chance to see what you can possibly do. I know I'm just copying and pasting code in, but I hope it's giving you an overview that you might not have gotten from a much longer stream on the technicalities and not so much on the what can you do with it and what do you need. Where am I? Yes. So let's say I wanted more information, or I wanted to fiddle with things, or just what if I just wanted to learn how things worked? If I wanted to follow a quick tutorial. The wonders of having example code, very nice. But you can see now that there's references in this matplotlib, which is so nice. Again, coming back to the point that like if you are doing AI, machine learning, etc., that you might want to use these libraries and they might help you out. And again, depending on what you're testing and what you're doing, different things serve different purposes. So we already talked about the PyEnv, conda, etc. Requirements.txt is very popular with like main.py kind of approaches to developing with Python. But you could also have a requirements cell that just has all your imports, and then you don't really have to worry about things. Again, very transferable. So as you play with things, you'll find that there are not as many languages that have the lovely nature that is Jupyter, where you can just try out code as you go instead of having to recompile everything and rerun everything and blah, 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 blah. Sorry, when you've been yapping nonstop, it is very horrible on the throat. But what does this mean for transferring to other languages, paradigms, fields, etc.? I've already shown you how you can transition or build on skills from AI and machine learning to going into full stack and doing data visualization, telling stories or making games or whatever. But if you decide that you also want to work with other languages or something like that, Like if you again stay in the AI machine learning world, focusing on math, you would then be able to transfer your skill sets to R, MATLAB, Julia, and a bunch of other computational languages. If you decide that you're more on the data visualization side, telling stories, you might consider the full stack direction of like JavaScript, depending on how you'd like to approach things. There's more out there than just that. You can also stay in Python for all you know. And then if you decide that you want to make games, you can again test out engines by like doing the math behind things before you jump into Unity and just arbitrarily use their engines as they are. And so different additional principles are behind some things, but it could be even that you have like a back-end Python server that handles most of the math for you, and you've already been able to visualize things, do what you need to do, test things, and then you might have a different front end and so on and so forth. So Python makes things very readable, also very math friendly, where you can pivot at any point. And if you just use Python to do quick demos, that's actually the most common reason I use Python is I just need to spin something up really quick, really understandable, test out the edge cases, and then translate it to another language. I most often write my parsers, my data like collections, my data processing, data anything really in Python first, work out the issues. Sometimes I'll go to Jupyter Notebook because I'm like, I need to test things like pieces at a time, and I just cannot be bothered to like write a whole file that I have to run a bunch of times that an API will eventually kick me out. Versus if I just hold that API response in memory in a Jupyter Notebook, I will always have access to the data that I'm manipulating, working with, etc., without killing my API access and whatnot. And so as a result, you can again translate into other languages. I've definitely done where I've gone from Python data parsing to Java because that we were switching to AWS. I've done where I switched it into Golang because we were using interfaces and we were very strict on our types. But the point is I was able to test everything out very quickly, very kindly on myself, where I had a better structure and knowledge in Python before transitioning to another language. So very helpful and friendly. So quick pause, questions, comments, concerns, because I would like to have us try to fiddle with Matplotlib, build together a small data set, talk a little bit about AI ethics as we get into the rest of the week. So that way, when you are attending these workshops that our other coaches are hosting, that you have a much better background of like, well, how do these things happen? Like what's going on really? And I already do see a question, which is what are my thoughts on no code solutions like LLM Studio, anything LLM or Nation? What do you mean no code solutions? Like drag and drops, like folks who already built something for you and then like you just have to use the API or something? Or I'm not sure I'm getting the question here. It's a very good time to pause because holy crap, my voice. Oof. No code solutions to what? What do you mean no codes? No code solution. Platforms to build without code. AV screening. Workflow automation tools. Insert code when you need it. Huh. I see. This is like Scratch, but for AI. Yeah, drag and drop solutions. You can use API or local APIs like Llama, build out of AI. That's a great question. I don't have an opinion, frankly. I've never used it. I've never done it myself because I came from a time where we were always having to import the model in Python and then like train it and do our own stuff. But I think that as far as getting people interested in using default options and things, it's a great way to expose folks to whether or not they can use the model for their intended purposes. And in that case, great. That's fantastic if they can just use it as is. But as you get deeper into the details, I'm pretty sure you're going to find that you might need to make adjustments, make changes, or have a little more control over what's going on, that you will start needing to pursue things outside of no-code solutions. And so I think it's a great way to be enthusiastic and then figure out where you need to go from there to actually make the like changes that you want, because sometimes those solutions are just not enough. And that's just sometimes a constraint of those, and that they're very much meant for like, how do you speedily get someone up with the minimal effort, with minimal engagement, so that way they can have that without the like oh, I need to customize this model to do XYZ kind of thing, right? So, yeah, no, that's perfectly fine. Python just is an opportunity to give you more control over things. So, to that effect, I actually was like, well, what kind of projects do we do in the last hour? And so I actually left it open-ended on purpose. Obviously, we will talk about scoping because we only have realistically like 45 minutes to properly put something together. And so I was wondering, what are folks interested in seeing as a sample project of a culmination of this work? Do you want to work through it on stream? I'm more than happy to work with you on breaking projects down, because another thing is, as you decide maybe that you want to do AI, machine learning, or anything, you probably want to start wondering, well, like, how do I make something accomplishable in a weekend, in a hackathon, in a month, in whatever the time period is? Funny graphs. What do you mean funny graphs? That could mean a lot of different things. Math art. Ooh. Okay. Oh, I have ideas. Math art. Let's see. Do you mean like fractal math? Do you mean like, well, let's just see what's online. Let's just see like Matplotlib, math art, Python. Let's see what's there. So PyPlot, how to plot math art. How would I plot one of these circle structures? Okay, so here's not funny math, but like here's how we could fractal math. Okay. I've never actually tried it before, so I don't know how far we'll get, but there's lots of math. This hurts me to look at, actually. Okay, so it looks like they've... let's just copy what they have. Complete code, copy, paste. And then let's understand what's going on. It's not plagiarism if we understand what's going on and we cite them. Let's go copy this. Okay, let's run this. Let's see what happens. Let's see it break. Because I'm just arbitrarily pasting code in from Stack Overflow. Hey, we have somewhat nice math. Pretty math. Okay, like what's going on now? Like, let's go look into it. So we know that we're importing NumPy, which standard import, okay, and great. Visual Studio Code gives us a quick preview, how to use the documentation, all sorts of stuff. Fantastic, we love that. And it gives us also lots of information about their sub-projects. Then we have Matplotlib, where specifically we're using PyPlot. And so that's not something we ran into, but it looks like it's giving us MATLAB-like way of plotting. Benefits to our transferable learning. Acts as a figure manager, GUI manager, love that. Great for interactive plots and programmatic plot generation, which is exactly what we just did by just pasting the math in and just being like, well, there was a for loop. Okay. Recommended for complex plots. Oh my goodness. And where was I? There we go. Create figures. I just give up. Okay. And then we have the math library where we imported sine, cosine, pi. Okay. Then we have n. We have a bunch of figures. And if we actually read through that article, I did not, but I'm guessing it would have had some of these equations that they're going through where they're just changing that n where each time they're increasing it. Okay. So let's say I have no math background, which the answer is I kind of do, but I also cannot be bothered to think about this in the next 5 minutes about what the heck's going on enough to explain it during a stream, because it has been a very, very, very long time since I have done this kind of math, like pre-PhD math. I do stats these days, which isn't that good either, to be honest. So we can see that like there's this cosine, but like what if we break it? Like what if we do a different thing, right? How does this change things? What if we swap this? Does the y-axis, if we just flip things around, how does this change the image? Does it break it? Does it make it better? Like, who knows? And as you can see, now we made a bone. Okay, so let's play with it some more. And maybe I want to make both of these sine instead. And if I run it again, and notice I'm not querying an API, I'm just playing with math. And now I made like a weird square thing. I would eat a donut that looks like that because it would be cool. And so I can keep making changes to scales. Like maybe I made this like 1, or let's make that 2, and let's leave that as is and see what starts changing things. This isn't actually fractal math, but like now we can see where things are starting to change. This looks like kelp. It absolutely does look like kelp. I think this is why I picked it, because I like kelp. I like the ocean. And I could even change the color. Like this one is pretty clear where I'm like, I want it to be green. So that way it can be kelp-like. And it's processing and thinking, and now we have actual kelp. Hello. Yay. Okay, but what if I change the line width instead of it being 0.1 to just, 1.0? What changes there? And so this is like one way of learning how things work, where you can just fiddle with things. Okay, this is disgusting. This went horribly. Oh my goodness, it is just blobs. What if I made it even smaller? What if instead it was 0.01? Like how messy will this become if we go in a different magnitude? And now it's barely there. It looks like an X-ray, to be honest. Okay, so clearly they were doing something right by having the line width be 0.1. But then we could also look into like, well, what else can we do with this function? Looks like we can give it arguments in the scale, we can give the data, and we can give additional things. It looks like, tell me more about like this. What if I change the color? What if I wanted like a hex code? It's very literal, but tell me more. So at this point, I don't know about color. What if I wanted it to be like, I don't know, like a very specific hex code? Then I might look up the function and be like, well, if I want a hex code, what would that take? Would it be a color function? Would it be like the actual hex code? Would it be, hashtag blah, 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 and so on. And so there's different ways to, what if I didn't make it 361? What if I made it 181? Is it only going to draw half the image? Nothing changed. Fascinating. I really thought that was going to change. I had no idea what I was editing in that instance. And so again, I don't know what this is, but now that I'm again hovering over things, I'm like, oh, lens space is actually evenly spaced numbers over a specified interval. Okay, that makes sense. I'm guessing this is from 0 to 2 pi, so I might actually change that to just pi. And then I would leave this as 361, where I want to have a bunch in that range. Now the shape is even weirder. It looks like ghosts. What is that? Here it is. Okay, so apparently we can like go get color maps. Apparently. Had no idea. Ooh. Ooh, that looks fun. Oh, but this is an R package. This is an R package. It looks like a swimming pool. ggplot. But Python. Wait, they'll find it for, okay, cool. Well, you find it for Python. Yeah, so math art. Matplotlib does it for you. We love that. What other things can we do? Python fractal math. Creating fractals in Python. Cool, a treat. This is very long. However, you could paste, I'm going to just share this link so that way y'all can try it on your own. So this instance, they're making triangles upon triangles upon triangles. And so they are giving you an explanation about, again, some other things you can use. Pillow is another common library I've seen in the computer vision side of things, by the way, and alongside NumPy. And so they have this very, very long plot line function, as well as all the other things. These could all be individual cells. And so that's something you might also consider, is maybe you have an import cell. Maybe you have function cells for each of the things that you're doing. And then you might say, well, as I'm fiddling with different things, I want to regenerate different aspects of it. And so as you saw, I was rerunning the code, but I wasn't querying anything was actually okay to rerun a bunch of things, and it wasn't terribly intensive. Like, yes, it did time to generate it because it was a very complex image. However, there's ways that you can section out your code in a way that you can optimize what you're testing, what you're doing, without having to rerun the whole file, which is also why I was showing you all Jupyter, because I'm like, well, why not? You should learn that before you jump into things. I wish I had planned a little bit of a cooler thing than just like, let's go Google what like fractal stuff is out there. Like once upon a time ago, I actually made a interactive matplotlib labeler for multi-dimensional images, which sounds very complex because it absolutely fucking is. And I had to get into the very deep depths of matplotlib about how it works and how it renders, and that was a choice. I've chosen not to remember most of that, to be honest. Let's see what I can find really quick. So as it turns out, someone has actually done what you all are asking. How do you make comical visualizations in Matplotlib? And it looks like they used a data set that contains a bunch of movie and TV show files. They installed it, required libraries. So this could be a cell where you load up your data. You only have to do it once. And then they started adding in the different features that they wanted to use. And then they XKDified, CDified their visualizations to plot stuff, which honestly is really cool. Oh, it's... Wait. No. I want to know more. Oh, I wanted to find it. Come on. Is this a... Wait. Is this something I can do with Matplotlib? I want to make sure. Oh my goodness, yes. Yes. Wait, I want to see that. Show me all the instances. How do I run this command? I want to know more. I really love XKCD, so I'm really curious. I wish they showed me the whole code, though. I would love to just see the whole code. This has just turned into me nerding out about things. I'm sorry. This is word clouds. With, how do you... Show me Matplotlib. How do I use XKCD? Huh. Plot.figure. I'm guessing because this is an interactive one, I don't think I can actually do that because I'm plotting things. Huh. Or maybe we indent this. I don't think this is going to work, but it would be very cool. I don't think this is going to work. This is not. No, it's not found. Wait, what do I need to install? No, I don't. I just... Oh, install the XKCD script font. XKCD fonts are not packaged with... Okay, how do I go do that? How do I do this? So you can make it fun. Like, that's really cool. Let me share this with folks. And then here's the font in case people want to try it. So that's something you can play with and see, like, find your favorite like math picture and then XKCD it, or find if there's other fonts that folks like want to use it. That's so cool. How do I just download it? Do I just clone the repo? Is there instructions? This is why having a good README is important. Ugh. Tell me how I install it. Okay, how to, yes, but tell me how to install. Download Jupyter Notebook. Let's see. So there's, as I mentioned, there are quite a few folks using, oh, stop that, you. Quite a few folks using, what's it called? Jupyter to do things. Oh, my desktop is crying. I know. You're struggle bussing. Come on. I know you're doing a lot. I know I have way too many tabs open. Come on. You can do it. Oh, it froze. It froze. My poor desktop. My poor desktop. Okay. All right, that is for later, but generator. That's cool. That's another thing you can do. You can do a handwriting. Actually, which does matplotlib need? Why do you keep screaming about these two? Wait. It kind of did it. It did the wobbly line at least. That's funny. All right. We're going to assume that it just uses the TDF, presumably. And then we're gonna go to downloads, and we're gonna go to repositories. Let's see if this one runs. Yes. The fun things you can find on the internet. In the meantime, this is a good chance to ask questions about getting started in Python and other things, because I've mostly shown you like what you could do, but getting started, I mean, the sky's the limit. And as you can see, people are already doing things for you, so like, do fun thing. No! Okay, let's go figure this out. All right, matplotlib find TTF files. This is under the font manager. Find font, blah, blah, blah. Let's go there. Import lib. Font manager. I would probably agree about installing it, but I wanted to make sure. It's been a very long time since I've installed a font. I'm learning many things today. Pretty sure I have a font settings. Please hold while I install font. Things I didn't expect to do today. Heck yeah, it's just a drag and drop. Yay. Let's go back to this and then go here and then. I don't remember it being that easy. I guess maybe it always was. Let's make sure it downloaded. Yes, it did. All right. let's try that again. Let's make sure that worked. No! No, wait. No, not quite. I need to zoom out. I can't read. Let's restart. Yes, restart. So we're restarting the kernel just to like wipe the cache, because sometimes that makes a difference. It has loaded things. It still doesn't like it. No! Darn. That's something I will hunt down. But hey, there's some fun things you could do. All right. That was not a pointless venture, but not one that I was happy about. Mostly people are doing installations. Import. Oh, delete fonts located in the cache. Given how deep this runs into... let's try... Close Jupyter Notebook. All right, friend. Restart. Just in case. Re-download. Rerun. Nope. Unfortunate. I will investigate that in the meantime, because I think that would be very fun for later. But okay, we've derailed on XKCD because why not? But point goes to show, again, Jupyter, you can do a lot of trying things out and testing and figuring out what you need to get things working. You could still run all of this on a Python file, and I can, well, let's see. Let's write a new Python file. So we're going to copy that over, and we're going to copy this part over. That part, not the... Let's get rid of the XKCD since we know it's not going to work, which sucks, but it is what it is. Let's do main.py. And do we need anything else? No. And so with this one, the tediousness here is, again, that you have to just run python main.py. And I do expect something of an issue, but we'll see. Alrighty. We did not have issues. Instead, okay, we had issues in a different way. All right. Come on. So this is a little more tedious, running it in main outside of Jupyter Notebook, where it took a little bit to generate, and we can't just rerun it. We do have to like close this window and reopen it and rerun the script, etc. And right now the script is hanging, like it's still running because this window is open. And so that is a downside of trying to do these kinds of matplotlib things and whatnot, that you want to just like, I just want to see a picture, or I just want to see math, or I just want to see this. Doing that in Jupyter Notebook is a lot easier than doing it in main, for the obvious reason being that it's going to hang your computer. It will be stuck there. Like, you can flip through things, which is fine and nice, but this is just a baby introduction to all the different things you can do. Yeah, I posted the XKCD code stuff to here. So there's that link. Let me go find the actual link I was using earlier. And here's the font for folks. And then here is the matplotlib documentation for XKCD. If you are curious or want to play with things, like, please do. Because there are, again, so many wonderful things you can possibly do. Like specialty plots. I've never heard of this, but that looks really fun to play with. Spines. Huh. What are these? Okay, normal. That's kind of normal. Okay, yeah. So you can embed Matplotlib. You can make them interactive, as I mentioned. All sorts of different ways to engage with things. You could even make it interactive. Again, I was building a labeler. I was using, I think I ended up switching from Tkinter to PyQt. So this is more like if you're trying to do GUI stuff, not necessarily games, but like labelers or other ways of interacting with things. So the reason I mentioned labelers is in generating data. Oh, that's the other thing. I was going to mention AI ethics, but I got sidetracked by XKCD. Sorry. I'm sorry, folks. But yeah, so labelers are one way to generate data, or maybe you're labeling an image or an object. That's how a lot of the old timers in computer vision did object classification, where somebody sat there and labeled this is a human, this is a car, everything in this box. And obviously now things are, of course, better where they've isolated an image, but somebody had to draw those things. And so with AI ethics, the thing that I wanted to mention is generating data is not enough. Creating a perfect data set is the worst way to do things. Because if you generate a perfect data set, you won't actually consider the real world. And most of the times, you'll probably use a model that already exists, has already been trained, has already done things, and you're just adapting it for what your needs are. But being mindful of where the data came from and who was involved in the data collection, whether in like what the consistency of the data is, etc., is important. So to that point, there are a number of places to get data. The most popular one is Kaggle, where you can load things into your Jupyter notebook, particularly if you're looking at data sets. You can go through and say, well, which one exists? And so something to consider is, well, is the data set vetted? Has it been used in a publication? Where did this data come from? And so let's see. Goodness. Where is a good one? Let's sort by actually. Let's see. Benchmark data sets. What you got? That doesn't look. Let's filter. Okay. So there's different ways that things can come up, which again, Pandas would be super helpful. You might do a CSV or JSON, SQLite, BigQuery, or other databases. Licenses are important to consider, particularly when you're using them, especially in a hackathon, if you're going to publicize things. But let's say original, clean data. Oh, you can only, I guess you can't pick multiple. Go figure. You might also want to consider file size, particularly if you're using online Jupyter notebooks on AWS. That's something you have to pay for. So that's something to consider. Let's see. Let's see what the usability is. Okay, so we have, let's say, Amazon Prime movies and TV show, or a fake and real news data set. That seems relevant. And so you might have a CSV that tells you, like, this is awesome. Like, this tells you what the columns are and what's going on with them, tells you which CSV is which, and you can use it for like NLP or text classification, and it gives you some examples. And so that's a very nice overview of data that you might want to use, for example, in a future hackathon project. Like you could also use Jupyter Notebook as a way to play with this data before you actually process it and do anything with it, and just get descriptive statistics. So descriptive statistics being like median, average, mean, mode. Maybe you want to get the skew of the data, or normalizations, etc., just to see like what does the data look like numerically, categorically, etc., so that way you can actually start to make meaning of it and how you're going to use it for whatever your project is. So coming back to that no-code solution earlier, it might be that you just drop a data set in and say train on this, and that's fine. But maybe later on you find that you are looking to like make an application out of it, that it's like, hey, can humans detect fake versus real news? Using this data set for an example, and you might like do a Tinder kind of an application where they swipe right or left on whether it's real or fake. And you might compare that to the model that you've trained, or you might say, like, does the model like do the same as humans, better or worse, and why do you think that? And so there's different ways to take projects in very serious directions or very fun directions, where it's like, if this is a fake news, how do you make this even more obviously fake, or something like that? Or like, there's again, many ways you can swing a project. Just be mindful of the licensing, which, as you can see, you're free to share, copy, adapt, etc. But you must give appropriate credit. So being mindful of what you're using. I'm sure many of the coaches might cover that. And again, show you more creative ways to interact with it. Yeah. Again, this workshop was very much meant to be a what can you do with Python and what are the resources available to you to get started. As you saw, we sidetracked into doing something fun because I had no idea you could XKCDify your plots. That's amazing. I really love that. But that may not be for you. Maybe it's that you want to make a custom font for your plots, or that you want to make your your plots drawn in a specific way, or that you want to take your science training and transform it into programming training, or vice versa. Python is the gateway to a lot of different things. As you've seen, there's so many directions you could go, and you can merge them all together even still. So if you're looking into more of the storytelling, I would say look into data visualization using Django. That will give you the dynamicism of updates, particularly if you want to show dashboards. Django is really, really helpful in that because you have the power of matplotlib through the dynamicism that comes from Django and querying other things. But if you're looking to just, get started, figure out things, want to do full stack, again, I would consider starting with Flask. If you're just looking to be like, well, what can I do with a model and how can I make changes and how can I, do different things with this data set, then consider using Jupyter Notebook and testing out the libraries that you might be curious about, such as Pillow, NumPy, Pandas, etc., or even just making your own data set and seeing well, what can I do with this? Or create a random data set of ones and zeros and say, how do I make meaning of this? Not genuinely, but to start figuring out statistics and the more of the mathematical backgrounds you'd need for more advanced research topics. And so on. But with that, like I said, this was very much a conceptual workshop. Any questions, comments, concerns? It looks like my internet is dying, so perhaps it's good timing to wrap this up and maybe challenge you in the 30 minutes left to find your favorite font on Matplotlib and a plot that you'd be interested in. Maybe share it in Discord, and I'll see if I can include it in a future Today in Global Hack Week. I think I'm running Today in Global Hack Week tomorrow. So if you can post in Discord a fun photo and tag me, I will finagle it into the presentation tomorrow as a thought to challenge you to just dive into Python and see what you'd like to jump into. Questions, comments, concerns? I know this was meant to be also a mental break before you really get into doing projects with folks, to kind of just expose you to terminology, knowing that a lot of the coaches are going to be way more in depth, but now you've already heard of some of these things and you can start looking into them on your own time. Hey, somebody already got it working. We love to see it. See, this is why it's very hard to stream and debug at the same time. So when hackers get it, I'm like, yes, more power to the hackers. But since you've made it, tag me on Discord and I will sort through them tomorrow before Today in Global Hack Week to show, but make it PG, of course, because it's going to be on stream. So if you decide to make a fun graph that you want to show off, let me know. In the meantime, I'll let you all go. I know actually who is coming up next. Oh, fantastic. So now that I've given you an idea of what's out there, you get a fun game with Kari and Kevin doing Scribble.io. But I do know that there is another Python workshop. So now that you've again gotten that exposure, join UT much later today into tomorrow morning if you're on this side of the world. Otherwise, flip that for the other side. UT is giving a finance with Python. There's also creating your first recommendation system later on tonight with Jocelyn. I don't know if it's with Python or not, but again, a chance to look into what you can do now that you have the initial conceptual background of what's out there. Great. Well, have a good one, and thanks for joining.